This is a SAS seminar, introduction to SAS seminar. Is not going to replace some of the SAS training that SAS corporation has. The purpose of this seminar is to get you know SAS, what resources is available, and getting basic start to the SAS and get familiar with the opportunity that SAS gives you. And if you like to use SAS for your statistical analysis, then by this seminar, you can start. Basically, this seminar has been designed for UCLA graduate students who previously didn't have any SAS training. And for the research, they are interested to use SAS. And that's, because we are a statistical consulting service in UCLA, serving faculty and students, people before me decided to create this. So client who wants to seek help, at least gets the starting of the basic of the program, then we are in the same page, then we can help them with their questions. And sometimes if we need, we can refer them to the resources we have. So for this workshop, you can go to the workshop note. And today we are going through these basically different chapters of this seminar. The design of this seminar is basically what you need to do in a data analysis setup. So basically, first you need to enter the data, then you need to explore the data. After that, you need to maybe do some modifying data, some data management, merging data together, or appending some data stack over each other. And then we get to the analyzing the data. I believe that the analyzing the data is in some way is, I cannot say easiest part, but is least time consuming. Preparing the data is very important to get a good data analysis. And then we have just some general information, resources that you can use for this seminar. So with saying that, my suggestion is you can download the data, use the SAS. We have a SAS code. You can either click here to get the code. You see, the code is like a text, but you can download it, or you can download the whole link by clicking here, save that file, and extract it to C. So when I save it, I can extract the file, right? And then I can actually, I need to go to my download and extract it to the C directory. Because the codes are designed in that path name, so it's easier for you. You don't have to change the path name throughout the seminar. So basically, this is what I mean. I have downloaded, I went to the C, and then I extract the data here. So if you go here and right click and extract all, right? First thing first, if you extract it here, it's going to extract c.sas data and then SAS data. So you don't need that. So we extract it in a C, right? And then if you extract, it's going to be here. Then if you open this folder, you will see the class node and the data that we are going to use. We mostly use the this HS1, HS0, the other data is going to be created throughout the seminar. So you don't have to worry about it.
Hey. Yeah. What's up?
I'm sorry, if you don't have any question, please turn off your mic. But if you have a question, you're free to open. It's not a very, I don't think it's a very big seminar, so it's easier to manage. If you have any question, you can just open your mic anytime during the seminar and ask your question. Okay, let me see. The reason I look over there is because I want to see if you have any question in the chat. And here, Johnny Lean and Andy Lean, and later maybe Christine will join us to help you with your question in the chat. And sometimes they can jump in and comment on some of the part and help you to get basic SAS going. So now you get the data, you set it up. Now what I want to do is go and open my SAS. My SAS is 9.4, and 9.4 SAS has different version. You can see the new your version here when you open SAS. Basically, you can see that this M6 is my software version of SAS. Later, we can see how to check the version, and you can actually type the code for checking your version of SAS. Usually, if you have older SAS and there is a newer file, then sometimes you get to trouble opening that file. But if there is older file and you have a newer version, usually you don't get any error when you want to open that file here. Oh, okay. Somebody asked where do I download? Johnny sent the link, so you can just click on the link. You can go to there is a zip file. You can download it and extract that document, that folder, to see partition of your computer. Okay, so this is SAS, right? When you open SAS, you see first these three windows. Another window is not seen here, is output here. If you click on each of the bottom panel, you see that panel open. So this one is editor, SAS editor. And also if you want to view those, you can click on the view and pick whatever you want. But the editor we use is enhanced editor. The program editor is the older version. You don't want to use that one. If you want to type your code, and usually is best way to save your code and run it, you need to use this editor. This editor basically is a text file. It's a text file. You can save it. You can open it in the text file, like Notepad. But SAS data file need to be open in SAS. You can open in, of course, in other software. But in order to run the data, of course, you need to have SAS. But to look at the data, look at the code, SAS code, you don't need to have SAS. Now, it's a good time to talk about what if you don't have, because SAS costs money, and most of us are getting SAS from our university, or we are a student. If you don't have access to in the for training purpose, you can always use SAS on demand or SAS University Edition. For that, I posted in the last email, I posted a video which is very well described how to register, sign in, and use SAS on demand. So hopefully you already set up your SAS or you register for SAS on demand so therefore you can run the code. I need to warn you that if you use SAS University, some of the codes might not work exactly the way it works here. For example, if you want to import the data from Excel to SAS, that might not work as well. But in that video that I sent you before, there is a way to actually call the library. We will see what that means, and make the connection between the data and the SAS data. So I will talk about that library and things like that later. But you can do that and read the data in your SAS Studio or SAS on demand. In fact, I think, Johnny, SAS on demand, you don't have to use academic like EDU. You can use your own like Gmail and sign in and use it. So I believe that. That in that video that I sent, YouTube video, they explain that's from SAS Corporation. So now let's get a little familiar with SAS and SAS window. You see the font here is very small, right? So usually, and for this seminar especially, I want to change the size of the font so you can see my codes better, right? You can go to the tool. And before that, let me talk about this. This is the log. Everything you run, the error, the warnings, and whether or not your data runs executed, it shows up here in the log. So this is a log of the code that we run. That's why we get this information about the session that we are running SAS at the very beginning. This is the editor as we get, and there is output. But about output, there's two ways to observe output. In SAS, there is a list output, which is this one. And there, by default, when you open SAS at the very beginning, SAS creates a result in HTML. Here you see is exactly like a Windows Explorer. You see live, but it's a little different. Okay, it's a little different. There is library here. You can see the library, basically the files that you read in the SAS and you work with throughout your SAS session. And then there is result here. This one, every result is going to be create one line here. So when you want to reach that, you can just click there, that part. And especially when you run a lot of code and you don't remember some of the code that you ran before and you want to check that result, that you get the result before, you can go and find it there. This Explorer is used a lot because sometimes you get the error. You want to make sure the data is there, right? Okay. I'm talking about the data. Usually you can think about data like a Excel spreadsheet that has rows and columns. Rows are each observation and column are variables. SAS is same as other statistical software, use that format as data. So it's keep the variables and each observation in the rows. And sometimes you might have many observations, the repeated observation in the rows. That's fine. Okay, but in each row is one information about one event or one observation in some level of observation. Now, I was going to the tool and I wanted to show you how to change the font. Okay, if you click on this log and go to the tool and go to option and click on font, you can change the font. You see, 8 is too small. Probably I go to 15. Let's see. Yeah, the 15 is good. I want bigger one. That's now. This is fine. I think output is going to be fine, but the editor is not. So I click on the editor. I go to tools again. Now I can go to option. Now I see enhance editor, right? If you click it, not the preference anymore. In here, you can change the size of your editor. I go with 16, maybe bigger. I can make it like not underline. This is fine, I think. And I have like a line, right? Line 1, line 2, line 3. I already did that too, so you can follow that. Let me see. I have show line number. You see, I click that. Probably when you start, you don't have that by default. Okay, you can click on that to see the line. So you can when I in one line in the code, then you know, and if you're lost, you know exactly where I am. So okay, this is bigger. Now I have everything set up here, and then you see something here. You can delete, you can break the code, sometimes run lots of time, you can break it, and this is the help. We get to that later. And this running man is executing code. So when you want to execute code, you can click on this. Okay. For now, I think that you know enough, but there are probably you can save. There is file, there is edit. Like any other software, there is import that we are going to use right now, and there's other options here. That guess what? That SAS is huge software. There's lots of other things that I don't know. Probably you don't know, and probably nobody knows everything, right? So we always need to search for things that we need to know and find the answer. You can search in the Google it or in the help, SAS help, and get your answer. There are SAS discussion websites also. At the very end, there is some resources in end of the session that we can and also recording. This workshop, by the way, is recorded, and recording will be available. We may use this recording or another version, because we did this workshop last year. Christine Wells did that, and she's very good. She has lots of experience, and her video is going to be also available. So now, okay, now I have SAS. What do? I need to read the data, right? So first thing first, I want, usually you have data in Excel, right? You can import the data. So you go to file, you put import, and you see this dialog, right? And from Excel. Here's the thing. If you want to import the data, make sure that your Microsoft Office is 64 and everything is updated. Sometimes there is a file that I had this issue. You might get that issue that need to be replaced and uploaded again. The new version, I had 2010. It calls, I think, Access Data Engine. And when you have that error, you can search for that error. There is a SAS help that you can follow and set it up. Don't worry about that if you cannot import the data here, because we have data in SAS format that we can read throughout the workshop. So that's not a big issue, but you cannot run the first part of the workshop. So now where, okay, I go to C, right? This PC, system C, and then this was my SAS data. And I can use this this is old Excel, right? I think we have a newer one. This one, I'm going to open this one. This is, the other one was so old, I think 10 years, more than 10 years old. And then, okay. And then it says which sheet you want to open. I want this one, okay. And then next. And then it says, okay, in library work, what you want to call this member. What that means, library work, as you see it here in Explorer, is where SAS keeps the data and work with them. It doesn't mean you cannot create your own library, you can, but this is the first library SAS look at the data. So this is default library for SAS. It's kind of how SAS communicate with other library. So I call it HS0. And then next, probably import with if you want to say, oh, okay. Now it asks you, do you want that import, because it creates proc import a statement. Do you want to save that? You can say yes. You can say yes, and where do you want to save it? I already have that in the data, the code. I don't want, but let's see. Maybe I can save it in this PC in C SAS data, and I'll call it the new name, my test code, right? Save it and finish. Okay. Now you don't see it here. Now if I go to the file, open program, and then reach out to this PC, system C, SAS data. This is the one that I created before, but this is the one I just created. This is the class node. So I'm going to open this. And you see, this is the proc import that I created. Wow, I created the first SAS code, right? Which is using proc import to import the data from Excel file. From the range is you remember we picked that sheet. There is another Excel, there is different sheet. You can pick which one you want, right? So now is a good time to also open. Oh, I closed it. I wanted to compare. Oh, you know what? I need to go to view and enhance editor, and then I can open program. Okay, this was the code that we created, and this is the program that it was in the zip file that I sent it to you before, right? So this one is good because it has all the command about each code, so you can follow, and we will do that throughout this workshop. But if you compare these two, you see when we did that, there is some options that is not necessarily to define, but it's is very similar to SPSS. it will be there. Some of them you need it, for example, range, DBMS, which is like a Excel. I don't have, yeah, I have Excel replaced. Oh, this is capital, this is lowercase. SAS doesn't care. SAS is not case sensitive. So that's one thing that we notice here. Get names, I think we need that because we need the name of each variable. And I could basically run this, right? So how I run it, I just highlight it, and then I use my running man. And then something happened behind the scenes in the log, right? If you go to the log, it gives you like successful. Wow, it was successful. I could, but it's a observation and 11 variable, 200. If you see 0 observation, there's something wrong. If you see warning like green or red command, that means warning. Is the font size is enough for you, or should I make it bigger? Is it good? Okay, if you do the same in SAS on demand, let me warn you, because when you do SAS Studio, there is a problem there. I have SAS Studio. I bring it here. Let me show you. Okay, probably you don't see it. Let me, I wanted to show you something that might, if you are using, I'm going to share the screen again, and I am going to share screen one. Okay, you see, this is my SAS Studio on demand. Okay, this was a class note, and I got warning like you did have warning. The problem is that when you want to use the import, somehow it cannot find that file. What I did this, live name in XLSX. If you watch that video, it helped you. And then you can use this code to basically make the connection between library work and the Excel file. So then you have that. Actually, you can create a library named in basically SAS libraries with your Excel file. So it makes the connection. It keeps the copy in here in, okay? But this is not permanent. I don't think this is going to be permanent. I think you have to later save it for yourself. But this is how you can read. Okay, that was for SAS. I didn't plan to talk about SAS on demand. I thought if you look at that video, you will be fine with that. But yeah, it's going to be a little difficult. Honestly, I didn't use SAS on it. I never needed it. Probably maybe another time. Johnny has more experience with the SAS Studio. And his workshop 2 years ago, he kind of encouraged people to use SAS Studio, and he used some example there. Okay, let me share the screen that I wanted to share again. Okay. So, yeah, we read the data, but this is not the only way your data is given to you, right? Usually, data are in CSV format. Even if you have Excel file, you can save it as CSV. CSV is a text file that comma separated value. right? Comma, separated value. So each value is separated by a comma, and then in next line, next observation, each value for each variable again is separated by comma. If you have missing there, then and go to next line, the value for that the variable are missing is going to be dot, is going to be missing in SAS. So be careful. Your CSV should be clean. If you have comma, nothing between a comma, then SAS get that value to be missing. In SAS, missing is shown by dot. Now, if you want to read CSV file, we use data. What that is? Okay, SAS has different steps and different procedure. There is a data step that take care of most data management, reading data and things like that. There are some procedure or proc that sometimes do the same thing that data step can do, but they are specific for a specific task. So when you see data, this is data steps, there is a lot. It's like a huge software by itself, right? It's not a software, of course, but it's a procedure that deal with the data management and data cleaning, data manipulation. And there is tons of, we use that over and over, okay? So every time you need to do something with the data, think about data step. And throughout this seminar, we will see that many times. So how the data step works. In data step, first, we need to tell SAS that where to do the data work for us, right? So when I say data temp, I set up a table, like temporary table, and I want SAS work in that table and put things together. And then that will be saved somewhere in the library. Now, usually I need to define the library, right? I need to say the library name, like work.temp. But library work is not needed to be specified. When you don't put anything there, means that table that you want SAS sort things out for you is going to be in the work, right? Okay. Because I already run this before, it's going to be here, but let's say we didn't have that, right? Okay. Oh, HS0 is here, but not temp, right? So, by the way, I didn't need to define library work. It's already there. It's default SAS default library. So SAS needs some space to do the work, right? It needs some part of computer memory. Now, I want to tell you this. In computer, we have two types of storage for the data. One type is permanent storage. It's like your hard drive, SSD drive, your before we had like a floppy disk, things like that. You can permanently store that, take it with you, or stay in the computer, but next day you turn on your computer, the data will be there. There is a RAM, which does communicate with CPU to do the calculation and computation, right? But all time, RAM were so expensive and was not that accessible. We had computer with 1 meg RAM, 1 meg, not gig, right? Right now, actually my daughter had this Chromebook with 4 gigabyte, I think RAM, or 2 giga, 4 giga RAM is amazing. It's like $150 Chromebook, and she's 6 years old, right? So older time, we didn't have this much resource, and SAS was written in framework computers. Because of that, the way they manage SAS to run the code was they couldn't bring all the data to the permanent memory, right? They couldn't do that. So the other one, we say solid state drive or hard drive. This one is not, is memory, right? So when you turn off the computer, the memory, the information will be gone. So all the time, they couldn't load all the data, all the information in the memory. That's why they had to line by line read the data from the permanent storage. So that's why that's why SAS is designed this way. There is advantage on that. When you have a big data, then you don't get out of resource, right? Our computer still is a big, but data getting bigger and bigger. So when you have 12 gig memory in your computer, that might not be enough for millions of data, millions of observation, right? So especially if you want to do something like join the data together or some sort of computation, and is not only you have to save the data in the memory, throughout the computation it uses lots of resources like regression model, things like that. So SAS, that's why SAS has advantage over all the other software, because it's designed that way to handle big data, right? So that's one thing. So when I have the data in work, that doesn't mean it's in the memory. That's what I wanted to tell you, basically. So temp is going still to be somewhere in your hard drive, but not is not necessarily somewhere that you have access to that. When you turn off your computer, and when you close your SAS, that will be gone. Okay, so you have to save everything in the work, because next day, if you want to, you did some work on that data, you want to work, you need to save it in a permanent library, which we will see that later. So in file, where the file is, and then you define the comma, and then you see what type is communicate with that data, the SD, and this one is important. If you have a character variable, you need to define the length of character variable, and then you run this code, and you see this $sign here. That means this variable, the variable before, is a character. So this is the program type. So this data is basically a school student with their performance and their other variable, like their ID, their race, their social economy status, their school type, their program type, their read, write, math, science, and social science, not social science, science, and social science score. So we get this run, and you see that we read this file. So if you go to work, now we have temp, right? So this part actually is one of the hardest hard for me because I came from different type of programming, like R to SAS. It was hard for me to get. Well, what that means that you have temp first. Usually you have the name of the file that you want to read from, but this is not like that. This is the name of the file or where you want to work with that data. And then later you can define where to get the data, right? So after that, you can print some of the observation, like temp first observation of temp, and proc print give you that. Actually, I can double click on this and observe this like Excel, but usually it's not the right way to, it's okay. You can just see, oh, this is what type of variable is that, things like that. And sometimes you can edit them from here. But anyway, you don't want to get them. We run print to basically get to know the data a little bit. So if you run that, okay, you see two different things happening. One here in the result viewer, right? This is HTML. And also in the output, you see the list of output. This is up to you to see the data this way, or you see the data this way and save it. And this is basically, if you go to the tool, I believe in the option, what's that? Not here, not here. Oh, customize, right? No, here. Forgot. View. I'm pretty sure is in preference. Oh, results here, right? You see that is a small, I know you can create listing. If you want the listing to still be there, you can still keep it there. And then HTML, and then you can say, oh, where, and then you can save it there, or you can just keep it in the work and then save it later. Okay, so this is the way you can decide how to see the output. Okay, so go back to the code. So we print first 10 observation. Another way is sometimes you want to enter the code. Usually this is not really the way we do the reading the data, but maybe you want, if you want to type the data or copy paste it from somewhere, you have to say, okay, first, okay, HSB10, right? First, you need to tell SAS where I put my book, this table, or that table. So where you want to do your work. And then SAS says, okay, here, you have to tell me, right? So here, I actually did input the name of the file. Again, $sign for program, right? And it doesn't matter you have 2 lines, as long as the semicolon. Oh, this, I should say that earlier. Every statement in SAS needs to be ended with a semicolon. Some other softwares, I know MATLAB needs semicolon, or it doesn't really care. If you finish with the semicolon, it knows the file, the line is ended there. If you don't, it just go up to end of that line. SAS needs that semicolon, and if you don't do that, it doesn't understand you finish with that task, right? You need to know what that finish. So input, so you say input this variable from this data. So it goes and read this, and first you put this as a name, and then put this for this one for this, and then read the data, put it there, and create a data set. Actually write it in the HSB10. Is not like other softwares. So it write it there for you. And then you can, it's basically somewhere in this system file, it's physically write these numbers there and save it. So, and after each proc, you need to do run. So it knows that you want to run everything here. And you finish with that data line with a semicolon as well. If you run that, it actually create HSB in Explorer, right? We see that result here, right? Okay, this is the data TMP that we created. You see this part here? This is basically this result, okay, is HTML. So that grow as you run more code and get more results. Okay, here it is, right? This is the data that we just typed it and saved it here. Now, let's print that, right? Okay, this is, you see, they come after each other. So we run this, we ran this one. This is basically the same, but it's a little different variable name and a school type. Okay, a school type was the character, program wasn't, sorry. And we did the dollar after a school type. Like here, we did the dollar after program, right? By default, I think it takes 10, length of 10 for that. But if you don't define it, but you can define that one. You can define how many space you leave for that. So you need to have enough space. Okay. Yeah, we did print it. Now this is what I was talking about. We had the work library here that had this data. Now, if I close my SAS, this will be gone, right? This data will be gone. What should I do? I need to save them, right? I want to save these as a SAS file. You don't need to put what type of file. It already knows it's SAS file. SAS data file, sorry, not a program, SAS data file. It knows the extension, and then now where you want to save it. First it asks, and then it says, now give me the books from temp, right? So basically it's saved from here to here. So this is out, in. So it reads from temp line by line and write in this here, this file, line by line, right? Line by line. So that's how it works. Okay, it cannot save everything together. It goes like line. It's kind of like closer to more computer language than other softwares. Other softwares also, let's say we want to save a Word document. Inside the machine, kind of things like this happens. It's just line by line save things for you. Okay. So when I do that, it saves this temporary file in HS0 for me. Data, the temporary data. And now I can print directly from here. I don't have, this is the SAS file. I can I don't need to bring it just do the communication. So ProcPrint can print directly all the data here. So this is all the data that we had. And you see some dot that is missing data. This is how SAS knows missing data. Now, here, I want to define my my own name, my own library, not the work library, something specifically for myself. So let's me go up to the library. So you see that work. I want to create a work library here. You know, in library, right? But I want that library contain the data, everything in here. So basically what it does is copy every data in SAS data to in here, somewhere in a library in SAS. So inside basically SAS software, it will be saved. Okay, this code, let me run this separately. So this is very important. Now, if you open this, you see all the data in the data. This is basically where most people start when you use SAS. We did the first import, but usually they define the library name or lib name, but this is basically library name. And they use and now, in here, I do a data step. But this data step, read this one and save this in here. If I do, let me do this. I do 0, 0, 0, 1, because I already have H0. I want you to see that if I run this, basically takes temporary data from work, because I didn't save work. By default, it understands its work. When I basically run this, and when I go to in, you see that will be here, right? So basically I copy, it's just copy between library. So this is the library you want to copy. If I had another library, I can just set another lib name. But I need to tell SAS that, where is that one? So basically it's copy this temporary data as this file in the live here. Now, what if I didn't have anything here? Or what about you try this? Okay, read HS test from this library and save it in work. How you do that? Just think about this simple question, and then we go type together. Okay, so I want to basically read this, copy that, and paste it to work. So later on, I don't have to type like in dot, right? I can, but let's say I want to use that. And remember, this one is permanent. This one, everything you do here will be there, right? When you close SAS, that data will be different, okay? But work doesn't. So sometimes you want to manipulate the data, but you don't want to touch your original data. So to do that, okay, where do you want to work, right? Where do you want to work your things? SAS asks you, where do you give me a table? So you say, okay, in HS test. So he knows is in the work, right? And then you don't have to go indent. You can just do set. It is just a personal preference. So you do set, and then in set you have to say in dot, which is here, this library. And what was the name? Was HS test, right? Semicolon. Don't forget that. I always forget that. Run, semicolon. And now if I run this, what happened? First, you can go and look at log, right? You see, test was 18 observation, and it happened. It says there were 18 observation. Read from the data set in this. The data set work has 18 observation with 3 variables. So it was successful. Let's see, it was successful. So if you go here, work, yeah, HS test is there. Now I can work with this data file and manipulate that, do things with that. And if I want to save it, I can save it back to in, which is my actually personal directory folder that I created at the beginning. And I want to save everything there. Okay, any question that you want to share with everybody? Exactly. Yeah, thanks, Andy. Any other question? If you want to talk about something, or don't be very quiet, audience, please. Okay, because we are very, not many people are here, so feel free to, most likely Christine says, mine was better and she will post it. So our recording is not being posted on YouTube, so don't worry about that if you. So, okay. Now, next.
So, sorry.
Yes.
Sorry
yes.
for interrupting. So I just have a quick question. So all these libraries, right? So all those are saved on RAM, or only in the working library is saved?
No RAM, no RAM. Don't think about RAM is hard drive. Okay, is in hard drive. It will saved in hard drive. But it's very similar that sometimes you're running something, and then for example, in Word documents, Microsoft Word, usually Word created temporary, and sometimes if your power gets off or something, it's automatically save that temporary file for you. This is kind of the same. So basically everything is in hard drive. When you turn off when you turn on your computer, Windows creates some temporary file to work with that files. When you turn off your computer, those files will be gone. Okay, the work is like that. But library in is not like that, because I connected library in to, I gave the address. Remember, I gave that address to library in.
Mm-hmm. Yeah.
So I tell that, SAS basically save it there for me.
Okay, so they're in memory. Okay.
Yeah.
Thank you. I have another question. So here, when you say, okay, some data, and then set, for example, temp, right? Set temp. So particularly that set, what does that mean?
Set means where to get that, where to read that file.
Okay.
It's more than that, I'm sure, but for me I think the best thing is to tell SAS where to read line by line.
So we're not sorry to interrupt you.
Sure.
We're not gonna go over this, but set literally means read one line from this file into SAS. So the way the data step works is it reads one line in, and then it processes all the steps afterwards Then when it hits the run, it goes back to the beginning, back to set. So it just keeps reading in one line and then processing all the other steps and going back. But you can just think of it as read one line of data from this file.
Exactly. So if I had more things here after set, right? When I say set, it goes to set and goes to first line, go and then run everything after that. And then when it goes to run, goes back to set and goes to second line.
Oh, okay.
It's a little complicated, but when you start working, you basically don't need to know all of those to get your data analysis run. This need, sometimes you want to use macros, SAS mark, things like that. It's helpful to understand the engine, how the engine works. Okay.
Okay. Yeah, I guess it's like a loop or something. Okay, thank you.
Yes, kind of.
Yeah.
But remember, because SAS doesn't have RAM, doesn't use RAM, it doesn't have any space to keep everything together, right? So it needs to go and read one data, do something, and then write it back.
Okay.
See? Yeah, that's how it works. It has to work with the hard drive.
Yeah. Thank you. Thank you.
Sure, absolutely. That sense, it might be slower sometimes, but it's fast. Actually, it's fast. But it's like a way like old computer program were written, because old time mainframes were huge, right? Huge computers, and they had tape to, like the Johnny said the other time, and you didn't have keyboard like that. You had to type like punch card, and then that's how they create the information.
Yeah.
And then so remember, SAS started in 60s, and they started 60s for mainframe in a university. I think they get funded by National Science Foundation, and then from there when their fund is finished, some people who start developing SAS, they came to, in 70s, they developed SAS for commercial use. And that time, remember that people were doing things by hand, kind of, right? So like regression by hand, things like that. So yeah.
Yeah, thanks.
Sure, absolutely. So let me go to a slide. So now we did the entering data. Okay, that was maybe the most time consuming. Now we know how the logic is easier. Now we want to explore the data. Things like contents, print, we already see print. Like some summary statistics, right? Some descriptive statistics, some like tables, right? And things like that, like plots, right? A little bit of plots, correlations, right? We are not in the analysis steps. That's why I always like to look at the data, do some basic, like what is the correlation between these two variables? Before I jump to the linear regression or things like that, I think it's good to spend a little time to really understand the data and get used to the data and what type of data we have. Then if we see error, a lot of error comes from where I didn't really understood the data. I use factor, for example, a categorical variable instead of a numerical variable, things like that, and then I get frustrated with those kind of error. But if you do these steps, which is descriptive, is very important. It's very helpful. So is it better to go to the code and run it, or you think it's better to go to the website? I think it's the same thing. There is some more explanation here. We can start here and then go to each of those code and then run it in. I think that's a good idea. Let me make it a little bigger. Okay. Now, this is just an option that how to report. So if you do option no center, the report you saw the result in HTML was in the center. This says no center, so it keeps in the right side. So just maybe you prefer that to, so you if it's the center, sometimes it's they're confusing. I don't know. This was the preference, but this is just option. Lib name, you know, some people say library name, in, call it in, and connect it to this here. So save everything here, basically. That's what you say to SAS, right? You say, oh, first of all, SAS knows this in, right? So it can make the connection and can get the connection with the data in this folder. Also, you can tell SAS, this is my path, basically. So this, we did that before, okay. Product content. Position is on option in the content. So it's just based on the position of the variable, the way they report it. And data in HS. You see the in is exactly this. Like, so you know, now this is the path. Just think about the path name that we need to define every time. And what content from which data, this data, and run. That's all, right? Content gives you the content of data. Basically, what is there in, it was before that, right? So yeah, I did this option no center, right? And did I do in? Yeah, I think in is there. HS0 is there. So I can just run these two together. And then I get the content of the data. So what is the data? Where that data is being saved? Who was the owner of the data? Or like in my computer is Jalal, right? And things like that. And then you have variable gender, numeric, length is 8, right? This is how this program type was character and things like that. So you get the sense that what those variables are, right? These are based on the position. This is based on the order of, I think this is alphabetic. Oh, this is alphabetic. This is the way that the data was there. So the data was saved in that file. Okay, and yeah, that when I say position, that created this for me. If you don't put the position, it just gives you this one. I can print it. We saw that before. Print. Where is the data? How many observations you want to print? Sometimes you want everything. Sometimes the data is very long. You want just to see the first observations and see how the numbers are, right? It gives you the idea about the data. How many, you know, it doesn't give you exact, it gives you rough understanding about the data. You can choose which variable you want to print. So you say var and gender, ID, race, social, economy, status. You can pick which variable you want to print. You don't have to print every variable. That's good. Sometimes you want to print 10 first observation of this variable and that variable and that variable. But let's say you have like 120, 160, and this is very regular to have, like very, very usual to have variable like data with 500 variables. right? But you don't want to have every variable, you want some of them, you can do this, right? Okay. Here it is, right? I like this one because I want you to. So yeah. Now, this was we did that, right? So we created temporary HS0 because we didn't want to manipulate the original data. We want to keep that untouched because maybe we messed it up, right? So that's why we do this. So yeah. So basically, again, repeat that again and again, because this is the part that you have to do it in SAS more and more. And this is something that I had hard time to really get it, you know? So it's okay. It's okay to really have. So I want here, this is your work, right? I can do work dot HS0, and then I read one line by line from in HS0 from the original data, and I can run it. It does the work. There is no result, of course. It does the work, but you see, it's the same thing. But if you go to explore, if you didn't have HS0, then how about this? I think I can delete it. Yeah, I deleted it, right? So let's do it one more time. Remember, look, work doesn't have HS0. Or there you go, right? That's what happened. So prog mean. Prog mean gives you summary statistics, right? Is it's not only mean average of the data, it's more than that. We will see. Okay. And now is a good time, I think I show you how to look at the help. Okay, it's, you see, it's not only mean, it's mean, a standard deviation, minimum, maximum, and that's by default. You can define what you want. Okay, now let's see. I'm curious, or I want to do something with mean. I know that mean does it, but I don't know how, right? So what should I do? You can go to help, okay? And here you can type what you want. Let's see if I can control plus. Can I make it bigger? No. I can make this bigger, but I cannot make this bigger. Mean. So I type prog mean here, right? And prog mean statement. I want prog mean statement. Let's see if I can see prog mean statement. Prog mean statement. Let me prog mean statement. This is just search, right? Statement. Mean statement is not there. Maybe this one. Okay. So I made it bigger and do that a lot, like the mean statement. I think I should look at the prog mean statement, but I don't see prog mean statement. But anyway, examples, right? Estimate covariance, estimate like testing on correlated different thing, but syntax is here. A single group analysis syntax. So I think it's a good idea to look at these help files and get familiar with those, because an overview, let me see overview. And then it says multiple group factor, things like that. But yeah, it's a little hard, but when you get to that, those help file, let me do the diff, because prog min is a little weird. Prog univariate. Like univariate the statement, right? This is better. You know, at least I know I'm looking some prog. So here you can see how that works, and you can see examples, right? And then with different purpose, right? And then this is how you can follow the example and see how those and it gives you the data. Lots of times you just can copy paste those and run it and see how that works, and explain more detail about that product. And okay, tens of thousand pages of SAS help, because SAS is a very vast, that has a lot of that applications in industry. So if you know SAS very well, for sure you have a job in industry. And because they use a lots of the corporation, they use big data, they want to make sure that they get the support and things like that. So yeah, it's a good idea to look at those and see how the other options works. And you know, sometimes you can find references there about that. Statistics, you know, kind of a statistical analysis, you know, like non-parametric. Also, you can do non-parametric tests using prog univariate, things like that. We will see it later. Okay, so I just wanted to tell you that how you can seek help from SAS help. All right, so you can do descriptive statistics using prog univariate, right? So you can say data, so prog mean gives the summary statistics about the variable in the data, but you can pick which variable, like this one. Here also you can use variable and say which variable you want prog mean, as you see after here. Okay, so if I do that, let's see prog univariate. Oh wow, lots of more things, right? So it gives you mean, standard deviation, some weights. Basically, we didn't have weights, so some of the observation, some observation, like some of add all the observation, but it does that for write, and then it does that for it does that for read. It does this analysis for every variable that you ask. Okay, skewness, cortesis, it gives you uncorrelated sum of a square. Basically, it's a square uncorrected. So it's a square each value in the data and add them together. Corrected sum of a square is correct by the mean. So x minus mean, every single value of the right read here, minus the mean, which is average, like this mean, and then a square. So this is good for calculating variance or a standard deviation. So this is the variance of observation. This is a standard deviation of a standard error of the mean. So it divide by n minus 1. Okay. Coefficient of variation. So it's just I think variance divided by the standard deviation. No. A standard deviation divided by the mean. Yeah, is a standard deviation divided by the mean. Why I don't get that? Oh, is mean by divided by standard deviation. I think. Yeah, is mean divided. What? I thought it was different. But anyways, So it gives you coefficient of variation. It gives you how variation is. Yeah, things like that. Still, I think is but it probably there is a square root of n in the denominator somehow to get that. But anyways, if you want more information about this detail, you can get at the very end of this page. And then it did the test. You see, the test where says mu equal to 0. It doesn't like test two like a paired or independent test. It tests mean against 0. Of course, the mean is not 0 and is not statistically significantly the average score is not 0. Gives you quantile, things like that. Okay. Oh, signed rank. You see, signed rank. This is how you get the signed rank test. Later we will see that. But this is for one sample. Okay, one sample. And later we look at that in more detail. Do you want some break and we come back in 2:25, or you want to continue? Do we want to continue? We can come back in like 3 minutes. Okay. How about that? And now let me finish that one, and then we go. And I finish in 5 minutes, and then we go and come back at 2:30. Okay. Thanks. Okay. So, okay, another thing, you can do prog mean, and then you can use a statement where you want that mean. Before that, we did the standard. You can, in the prog mean, you can say which summary statistic you want, and then is more than default, you can run it. Okay, and it gives you variance as well. You can say where the value mean. So I want the mean, okay, a variable read and math and science and write, where for people who had the reading score bigger than 60. I want to see how their mean is of other, how they do in other, and then maybe compare it to other group, things like that. So you can do prog mean and then run it, and it gives you the mean. And then this is the, oh, okay, 59. Everything else is better, right, than the people who, all the students together. So that means they are somehow correlated, right? And then I can do median, standard deviation, things like that, right? But, okay, here's the thing. I want read, math, science, and write, but I want to separate it for different group, right? So in SAS, when you want to define a grouping variable, you use class. So class statement gives you social economy for different social economy status, gives you this, how many people in that social economy, what is the mean, median, standard deviation, and variance of these variables, okay? So basically, in this data, it does calculate all of those, but for each separate group. And here it is. For this social economy status, this is how many observation, and I get this for each different group. You see? You might be interested to plot the data here, actually do the histogram and compare it to the normal distribution. This is how you do that. Later, very soon, we see that you can use SG plot, But here, just no print means that don't give me the result, just give me the histogram, right? Give me the, for variable right, I want histogram, and this, you see that slash means option. So you can add options after that histogram. So usually, stats is not very consistent with their logic of the code. Is some prog is different, but yeah, you need to know each. But help is always our help. Okay. So here it is. Still, I got the print. But I got some good. Oh, okay. I didn't get some of the information, but I get some summary statistics. I get the mu and sigma. I get the sum of goodness of, because I said normal histogram, it kind of like a smart, I would say it does that test for you. And it tries to see, to give you the rough comparison between normal distribution and your data. Okay, so that's good. That's very helpful, a lot of it. Now, if you have a categorical variable, you cannot do the histogram, of course, right? You cannot do mean, standard deviation, things like that, right? We use prog frequency because you have how many in each category, right? So for that, you can use prog frequency to give you table of how many in each category, right? So if you run this is for us, just for one variable, single variable, frequency in each group that we see before, but you see percentage of people, you see cumulative frequency and the cumulative percentage. Okay, now, as I said again, each procedure has a lots of other options. So a lot of things that you, in other language, you need to use different command. With one command here, but different option, you can do a lot of more things inside. So if I do this way table, I can get table for this variable, and this variable. There is 3 categorical variable. I can get a separate table for each one of them, right? So this is for this one, this is for this one. In your node is actually otherwise. So first you see the 2 by 2, I think, and then you see this. But in this code is a little different. So first they did that, then they did. Now, here I can do a cross tab between program type and social security, sorry, social economy status. So by this star, I do that. Okay. So you see, now you have a 2 by 2 table, not 2 by 2, it's 3 by 3 table. And you have percentage. The first one is overall, this 19 divided by 200. And then there is a by row percentage and there is a by column percentage. So first is by row, this one. So if you add this value and this value and this value, you get 100%. If you add 40.43 and 34.04 and 24.53, you get that. Why my result is little? Oh, I think because of the position. Enhance. Oh, you know what? Result, you can, this is HTML, you can just control and plus, it makes it bigger. Okay, now it's better, right? This is because it's HTML. It's not like others, right? So I can make it bigger and so you can see the result bigger. Okay, and then you can do correlation between two variables using CORR, C-O-R-R. So there's two ways to do that. By default, when I do define variable right, read, and science, for each pair, it use the available information. So if you have all available information for write and read, you use all of that 200. And if you have, for example, 100 science, for correlation is use 100 science and 100 between read and science, right? So this is one way they call it pairwise deletion, but anyhow. So yeah, you see, for this correlation between read and write, you use 200, but correlation between science and write, they use 195. There is another way. You can define an option no miss. So completely ignore all the missing, even if they have at least one of the variable missing in here in this report, which is usually used in data analysis. So you see, for all correlation, you use 195. Only the available, every variable should be observed to be able to calculate correlation, right? Okay. And then you can do a scatter plot, matrix scatter. That's very good. You know, just with one option, not only you created the correlation, you created the scatter plot matrix of per variables, right? But you can do a scatter plot using SG plot. So if I run this SG plot and then X variable or Y variable, you get a scatter plot of these two variables against each other. So you see, read in the X-axis, write in. So this is good to see if you should run a regression. And then you can do marker character to actually create the ID like this. So you can put the ID of each pair. So this student, for example, has lower writing, but their reading score is very high, something like that. And yeah, you can do it by group, which is very simple. This is nice because you can just, for example, what about female and male, for example, right? So if I want to, some of these students are female, some are male. What if I want to create that? You can do that by group gender by this option. Of course, if I tell you that even slowly and you write it, you forget. So rememorizing the code is not a good idea as long as you know what you can do and what kind of procedure you use. You should use every time you want to see how you can do that. It's very easy to use the help. So you see, there is gender. Blue is for gender 0 and red for gender. And yeah, you can do. Oh, this one is interesting. You can do the bar of mean of each variable right as response, but in the x-axis you can have so for example, you want to compare the writing score for different SES group. you can plot it in the bar, which I don't really like bar chart for that, but this is how, in some journals they do that. I like box plot more, but you can do this. And then you can do a bar, like a confidence interval bar for each of the mean, for each group, right? So if you run that, you see, this is the average of writing a score for when the social economy status for that students are 1, and the average writing score is lower than other two. And this is the confidence interval. And this is for social economy 2, and for social economy 3, actually the writing score is really good. It's much better than the other two. So there is again, there is a relationship between writing and social economy. So if you do some kind of like regression, writing as an outcome, social economy as predictor, that might be the good idea. And you can do normal and kernel density for variables. So this is very similar to that normal, but it also give you the kernel curve. So this try to fit the data. This is the normal distribution. So you can see it's not that bad, right? It's almost normal. Okay, so that was kind of like descriptive statistics, going to see how the data are and things like that. Let me go to the notes again. This is, I wanted you to see at the very end of each chapter, there are some resources related to that chapter that you can see. For example, descriptive information, exploring with graphics, things like that. And then I can, you have frequency as question. Actually, now we are here. It's a good idea. I show you. In our website, if you go to software and SaaS, you can see our resources related to SaaS. There is different classes there. It's been before. Recording is not there. We just started recording our seminars, but you can find a resource and find the solution there. There are learning, there is frequency as question specifically for that software. And yeah, you can see annotated output, that one that gives you in SAS, for example, descriptive statistics. I'll go to SAS. For example, the univariate, they wanted to explain what are those, each of those are. Here it tells you exactly. Okay, so it basically gives you the, yeah. So it gives you basically define what are those annotated output like this, right? So there's N is number of observation, things like that. Okay, going back to here. Now, where were we? Exploring modifying the data. So they, as I said, data part is the most, things that you really need. Usually we have problem with analyzing the data. The code is there, you just put it there. In SAS, it's very easy. Okay, modifying the data. We did some modifying before, but here we do more. Okay, so here we can define the format of each variable, label variables, or label level of a categorical variable. We can rename a variable, and we can use the if statement, and how to use functions, not to how to create a function. Okay, don't get that mixed with creating the function in SAS, there is a actually there is macro that you need to use macro language to create a function if you want to. So that's a little different. But this is like how to use SAS functions to create a new line. Okay. Again, in library in, we use the HS0 data, right? And then we did that. So let's pass that proc content. Maybe we can do it. Actually, I don't need to copy it. Is there? So yeah, the library definition, we did it. So we can do this, and this gives you the content again of that variable. That's first thing you do always. Okay. And then you do the print. And now let's say, okay, and also we did, let's say, actually we did read that permanent data in work, right? HS0. So we can work on that, right? Be careful when you do modifying the data. Sometimes you don't want to save over the permanent data. Okay, so let's say I want to define a new label for a school type instead of 1 and 2. Okay, if I look at the print data, right, a school type was 1 or 2, right? Let's say I want to change that with different label. It doesn't change the value of the school type, it changes the label of the school type. And then I can add that, for example, in print, in table, or in a plot. Okay, so I define a new format for which I call it SCL, and then I assign public to Y. This is like creating a new label. Is in like a data when you create a label, and then you have to you assign that label to some variable that you use. So in SAS, first we need to create that label. So for value 1, the label is public. For value 2, the label is private. So I create that one. Again, there is no result here, right? But in log, you see that happen, right? So I define the format for SCL. This is a new format definition, actually, I created, right? Now I can use that format. For example, if I want to create a table for a school type, but I don't want to have 1 and 2. I want to have word. I want to have private school and public school, right? How many private, how many public? In code books of the data, usually you know what that 1 and 2 means. So if I use private frequency, but I say format of a school type is SCL, it actually make it like that. So if I didn't have the format, it was 1 and 2, now is public and private. So this is how you label your tables or your plots. Remember, if I do content, the school type here, nothing happened basically in this variable, right? You don't really see that because you didn't change the label on the variable permanently. But you can't do that permanently. You can do the format. Again, remember that set was in HS0, right? Data is where you want to save it. So read that from here, right? Read the data from HS0. We do that formatting, not in the frequency. We want to format that school type in a new data set in the work, right? This is work. You see that? So I read the data from data file, each line, but this time I make sure the school type is in this format. And then I attach that label permanently to the data. So if you run that, go to Explore, in oh, format is here. I think, okay. So HS0. Okay, yes. This is like a SAS system, but this is the format that we create. Yeah. So now if I run content of this SH0B, let's see what happens. Then you see that data changed. You see, there is a format. And this dot, notice this dot. You will see that. Oh, this is the dot that we put in. Anyway. I think we need to define that dot so it will be there. I don't think that works. Yeah, it doesn't work with that, without dot. Okay. If you want, label the data set, then you can label the data set here, right? In the parentheses. This is a different way to define option, like do the procedure, right? We said like data here, but we didn't use the parentheses before, right? In data steps. You can do that and you can label the data as this. So this is basically giving a name. It doesn't do anything to the data itself. It's just assigning a label to data set. And okay, of course, we need to read it from somewhere. We read it from work. Now I label, instead of labeling the different level, I label the variable itself, and I call the name of the variable type of a school. Now let's see. Is data step, there is no result there, right? But if I do the content of that data, you see there is a label type for that data, and there is also we did the school data. Oh, here, label for that data, here. Before was nothing in the content, right? But here it happened. It doesn't do anything, it's just a label for the data set. If you ask me what is the benefit, I really don't know. We can ask Andy. Andy, do you have any comment about the benefit of defining the type of a school? If is there.
The benefit of adding a variable label is just to give you a longer explanation of what that variable means.
Yeah, that for label, but what about the name of the data? Nothing,
Same.
right?
Just to give it
Same
a
thing.
longer definition of the data set, what's in the data set. Yeah.
Right. Probably later in the print, we can use that, right?
Right.
Yeah, okay. So that's for that. I think we did that, right? No, we went back. Okay. You can rename the variable name in the set as continuation of set statement. But remember, as Andy said before, set is doing line by line, right? So, but when I run this line, when it renamed it doesn't rename the whole thing, rename the whole variable, because when it goes to the second, this compile everything together and do it for the first line. So it still knows this variable name. So it doesn't give you error. I expect that gives me error if I was writing this code in R, but in SAS you don't get any error, it works. So when I run that and then look at the content, I will see instead of a school type, I see the name public. For gender, I have to see female, right? So you see a school type was public now and gender is female. So I changed the name of the variable this way. But remember again, I am not touching this data, or there is no HSB actually here. I'm working on this data here, this HSB, HS0B. Okay, so later, if I want and decide to save it, then I can save it that different name. So that part you should be careful. Don't lose your data. So, or the better way is to save the data somewhere as an original and then do the analysis, do the thing, and then at least you have it saved somewhere. Now, I can do everything together, right? I didn't have, if I want to define different formats, I can do it. I can do all in one format statement, right? So for a school, I can do public, private. For grade, I can have like grade F, D, C, B, A. And then I can do female and male instead of 1 and 0, right? 1 for female, 0 for male. And I define this all format, all with one sentences. So usually it's a better idea to do one by one. And then when it works, everything fine, then you can put them together to have a nicer code, right? More organized code for others to read. But yeah, so when you don't get result, it's always good to check the log to see if that code works. Because if you see error later, you don't know where that error comes from. So yeah, when you see the result, then is another story because you already get the result. That means the code ran fine. Now, I do data steps to change the label, and then I change the name of the variable. But now I don't touch HS0. I create another data. I save it somewhere else, and I read it from the original. So remember, the original, the name wasn't female, right? If you don't put in here, you get error because in HS0, now I don't know, HS0B, HS0 might be different, but if you change the name before, it doesn't recognize, it doesn't understand what gender, what is gender. There is no gender anymore, right? So be careful. So I do the renaming of this. I didn't have to do this. I could rename it separately, okay, using the rename statement. Like, it doesn't, it's not here, but if you look at the slides, you see that there is another way to do the rename. You see, rename gender equal to female. In data step does that, but you can do inside the parentheses, inside the set statement. So two different ways, right? Okay. We were inputting things together. Okay, now you see a lot of other things that I need to explain it here. So we had that format, we had that rename, a school type, we assigned the label. Oh, no. Label of the variable, sorry. Label of variable, we say type of a school to explain what is what that means, you know, for someone if they had the data and they don't know, and you don't give them the code book. Then we apply the value label for each category of that school. So we assign that labels. Oh, female, also we created that, female and male. We do assign that one. So FM dot, so to assign that, you need that dot. This is the syntax in the SAS. To say this is not like a variable, right? So I think that's why they put dot to SAS understand. But again, SAS does things in different statement differently. So yeah. So for this format statement, they needed to put that dot. Okay. Now, I want to use if statement, right? So I want to create a variable named prog using program type. Let me see. No, I think I had the, let me see the content. I think the content was prog variable. Oh no, where I'm looking. You see, I need to look at the result. Somehow I must be managing with it. We were putting them things together. Okay, we were here. Yeah. We had read write program type, character 10. Yes, okay. It was character program type, was academic, general, and vocational. Now we want to create a new variable. So it check if that program type in each line, right? We say the set, it goes line by line. If it's academic, then it creates, they put the value 1 for program. If it's general, it put value 2. If it's vocational, it put value 3 for program. So this is how you can create new variable and assign different value to that. So it's just kind of like 1, 2, 3. If you want to make it like numerical values, maybe, or otherwise. Okay. Now, if race is 5, we put missing. Okay. So this is the how do we recode. So same thing, but everywhere they say race equal to 5, put race missing. And then we can create a new variable by using a sum function, right? By this read plus write plus math. So again, this is like line by line. So for each student, it adds the read score, write score, math, and science, and gives you the total score as total performance, school performance. Now we can use this variable total in another if-then statement. If total is less than 80, give them grade 0. If it's between these, like give them grade 1 or grade 2, or right? But remember, grade was F, D, right? We can assign the level for that grade. So A, B, C, D, F was the way we defined that. A for 4, B for 3, C, D, and F for 0, and dot if the total grade was missing. So if any of the grade is missing there, the total will be missing. And if the total is missing, then the grade is going to be missing. And then you can run it. So you see, we had a set statement. Now this is exactly what Andy said. SAS goes through line by line from the set and write it in here. So write that in HS1. And let me run this thing. Actually, I think I didn't run the format. I can run this. And then you can just use the running man and you get the HS1, right? So this wasn't existing work. You use HS0 and create all those variables. Now, if I want to see the content of HS1, I can see all these new variables, total and grade. Here, 14, the last one. You can say position, so this goes sort by the way they are generated or created, or is in the data. And then you can see the first 20 observations here. Oh, it's a good class actually. And this one is missing because total was missing, because science was missing, you see. So things looks good. And then we have this program that is 2 when program type is general, and is 1 when program type is academic, is 3 when program type is vocational. So, and we have the total score. So this is kind of data manipulation that you do. Now I can do the table, but remember I defined the label for different level of those. So when I do that, then I have public, private, male, female, and it makes more sense than before, right? And then now I see everything works, the data is fine. I can save that to that folder that we had, right? The folder that we thought this is the path of the folder. So, and then there is no result, but log tells you if that worked. Okay, sounds good. Now, if you have a format for if you want to categorize a continuous variable, you can do that. So you say, okay, call a score between 25 to 60, lowest score, 61 to 80, high score, and just create this format for me. Okay, create that. Now you can format read as a score. Now let's see what happened. Mean is the mean. Read is the read. Is not separated by different format that as low and high. It just gives this level, you see, for the score, right? But you can use that class read, right? The variable read still is a continuous variable, but you define okay, here is it. You don't have to define another variable. You could define another new variable as a categorical variable using variable read the same way that we created a grade variable. But here it says you don't have to. Again, there is different thing that you can do, and then we could use like that grade variable, but it says still we can use that as a categorical variable. But remember, read is a continuous variable, and if you run it, you can see you have for low scores and high score, so it's embedded in that variable read, right? We give some attribute to variable read that is more than a just continuous variable. Make sense? But again, we didn't have to do that. We could create a new variable, let's say categorical read, and then categorize that read as a new variable and then use that. But this is another way to attribute that categorization to the variable read and use that as a class. So you can see the mean of total for different level of the read. So mean of total for when read score is low and for who read score is high.
So when you change it,
yes.
So when you change it, it's like the standard deviation, the minimum and maximum figures changes, right? Is it
Yes, but remember, this is total. This is the mean of the total score for people who had lower score in read. Sorry. So, okay. So this is the read score. We defined attribute low score for whoever has the score from 25 to 60 and call them low score in reading. So they need to improve their reading. And then we define 61 to 80 as high score. Okay. Now, let me run this one more time. So minimum and maximum was the read score is between 28 to 50, 60 to 76. So it doesn't matter. You can use like 100 or 80 because there is no one get a score more than 80. So basically people are between 28 and 76. But we categorize. We say these people are low score, these people are, but we didn't create a new variable. without creating new variable, we get the attribute to variable score. Now we can use that attribute and then for each subset of the data, one for people who for a low credit score, one for a high credit score, we can get the mean of variable total. We can get the mean of variable right. Doesn't make sense to get the mean for variable read itself, but we can do that too. So yeah, that's what it is. Did I answer your question?
Yeah, you did. Thank you.
Sure. So 151 student have a score lower than 60, they fit 25 to 60, and 44, they have 61 and above. And their total score for that group is this. A standard deviation for that group. Minimum is minimum for that group, right? Maximum for that group. Yeah. Okay. Oh, by the way, this n is the n of the one that we without missing in the total that we compute these means, right? This is the total observation of the reading score. So this n observed is different than this n. This is actually observed total n that used for these calculations. You can use okay. In R, when you want to use a standardized, you use a scale, or you can use like value minus mean divided by a standard deviation to get the standard deviation 0 and 1. In a Stata, there is a prog standard that standardizes the data, any variable in the data, with the setting, this is set mean and set standard deviation. When we say mean 0, a standard deviation 1, it makes the standard deviation of the output to be this. And then out is the output variable. So data is HS1. Which HS1? Is it in work? Or is it in live in? Do you know? Anybody can answer that? Okay, this HS1 variable, where SAS gets that? You see, I didn't put in dots, right? So it gets that from work. And it makes the mean. The output is another variable. So if you run that, it's kind of, remember, we didn't use the data steps, right? But we created, so there is not only data step that can create a new data or save the new one, right? You can use this prog standard or different kind of prog also can do that. So HSB1B, this one. See, now if I do print content or if I, content now, but if I do print to see the value, which one was that we standardized? It was read and write, you see? Oh, it's not the score, right? The mean. Now the mean of this variable is 0. A standard deviation of this variable is 1, and the same for right. How I get the standard deviation and the mean for variable read and write? Can you think about that for a minute? And if you know the answer, type it in the chat. So let's see. I want the mean and standard deviation. Prog mean, right? Summary statistics. prog means, right? And then what? You can look at the other codes here like this. So data, I need to give data, right? Data is equal to, and I want HS1B, right? Semicolon. What variable? Var. And then I can define the variable name, read and write, and then run, right? So what do you expect for mean and standard? So this gives me the summary statistics, right? So you see a standard deviation is 1, mean is almost 0, and this is because of the correction, like or digits, but it's almost 0, right? Okay. See, so that's what we did to make it a standard, right? Okay. Now we can use SAS function. Instead of just adding them together, we can say sum of read, write, math, and science. This is how they define the sum. You can use like total 2 like that. Or ordinal 3, read, write, math, and science. Or the mean, the average of read, write, and math and science. So and this is like a title, nothing. You can define the title and then use the print and title it. But so this one ran, right? And then we defined the new variables. And now we want to so x3 total 2 total and the mean. See what happened. So you see, yeah. So x3 mean total, so on. Ordinal is basically which one is third place. So the which one is from high to low is third and gives you that value. So that's for that. And this is for how you do like manipulating the data, right? We didn't do like a whole data set management. We did manipulate the variable, label, things like that, right? Creating a new variable and things like that. We didn't drop, for example, any cases from the data or like subset. You can, but this is managing the data. Any question on that so far? So now I guess it takes more than what and again, at the very big end, you can see some resources about labeling and creating recording variable and standardize and things like that. So next one is managing the data. So in this, it talks about live name again, and then if so conditional statement, as we see it before, like we saw where keep drop, keep some of the variables, drop some of the variables, but this is, it doesn't print the variable that you choose, it just drop that variable from that data. So this is basically like a whole data set management. You can sort the data and you can append the data using set, and then you can merge the data. This is kind of the things that you might want to do with your data. So, okay. Again, library, it was this. The same library he had. Again, I look at the log, come back here, and then I can print sum of observation for some of the variables. So I write with size. But this is just a printing, right? Now, if I want, and then also you saw that how you can have, for example, summary statistics for different groups. You can create different grouping variables, things like that, right? But let's say we want to split the data and save each part in different data file, right? So here's the game. We want the alt, right? We want to create two data sets. You don't have to have one data set. You can define different data in the data set, right? From where you can read from this data, HS1 that we created before, and we saved it in our permanent library. And then we can say people who have bigger than equal 60, then put output in this one, right? If read is less than 60, then output is this data, right? So these two is, where are they? They are in work, right? Remember, we just, when we don't have work dots, that means is in work. So if I run this, I create two temporary data file, people with high read. I split the data, but it's not like a split, is physical split. And if you look at the log, you see everything works. And then look, now you see the title, you put the title on progme. So if you run this, before we did that, right? Before we did that differently. But this time we use the data from this data. Let me go to Explorer and go to the work. It was work, right? So in the work, I have low read, I have high read, right? If I print low read or high read, it's only that few people with that low or high. And then I can just do another, right? But we did that before, right? We could do that different way. Remember, we can just attribute that to categorical for read, to variable read, and just do the progme, right? So that's for that, how to split the data physically to do data set, and then you can do data analysis for that data set, right? So okay, if you do title like this, that means just ignore this title. Don't put that title over and over. You see, high scoring, low scoring was title. If I don't clear that one, it will be in all the other other codes that I have. So that's for that. Remember, I could do that, where statement and this, and get high read. I did that before, right? Oh, I did that like to separate, like together. I could do that one, only get a high read and then only get a low read. But what's the point? If you want to separate, you can separate it at the same time. And then you can print. And you see, this is the student with the read score higher than 60. You don't see any number lower than 60. And there is 56 students, right? Now, this was like a filtering, like a filtering or selecting some of. Now, what if I want to have a data set? You can do that with Excel easily, right? But when you are in SAS, sometimes you don't want to take the data to Excel, come back here, right? So you can just delete or drop or keep some of the variables. So this one is keep. So it keeps ID, female, read, write from high read. So it keeps those. Okay. So if I do that again, no, I'm sorry. If I print that for this one, copy and put it here. If I print that, I only should have this one, right? Yeah. So those variables only is in that data set, right? But the high read is still there. But when I close SAS, what happens? If I don't save it, they will be, you will lose all the work you did. But always you can have your SAS code saved and you can repeat that, right? But a lot of time you deal with the very large data. You don't want to redo the lots of data steps, and then you miss something. Then later, this kind of thing happens. So it's better to save the cleaned data file so you don't have to do it over and over. So we did that one. We can drop, you see, instead of keep, we can just drop. All of those are data management, and we do that in data steps, right? Now, appended the data. I said we can use the set to append the data. Basically, you read line, you put it somewhere, and then you can have another data to read line, and then put them together. That's what append does, right? So that's what the set actually does for you, right? So if I do that, I get the frequency table. Oh, okay, they use already male data. They didn't create that, I think. Did they create the female, male? I don't think so. We could. No. So this is the data that was there in the data set that I used, right? I put in. It's not from work because I didn't have that female male in the work. I don't think so, but I could make it, right? And then I created the frequency table, okay, like this. So 91, 100%, right? Of course, because it's only one level. And in female, only one level, yeah, 109. So this is already split by female and male. Now I can append these two data together to get one data, to get back to basically the data that I had, right? So I can. So for that, remember, I'm creating a new data that append these two files together, right? And it's again, set was reading, right? Reading. So if I do that, and then I like to print. Um, and e dot it is actually, you know what, I want to, because this was there already, I want to do that and put in the work. So I have the master here, this one, and then print HS master.
Josh, are you there? Maybe it looks like we have a little bit of technical difficulties. Is he frozen for other people too?
Yes, he's frozen for me.
Okay.
Yes, Jimmy.
All right, let's give him a couple minutes to recover. If you have questions, you can ask now and I'll try to answer. Otherwise, we can just wait a couple minutes for Siavash to recover. Hopefully he'll be back in a second. Back? You're muted, Siavash. You're muted.
Sorry about that.
Okay,
My
you're back.
internet got disconnected for 1 second.
No problem.
So sorry. Yeah, and I need to share. Okay. So I wanted to test and then do the run. Okay. Something went wrong.
You forgot data equals.
Oh, okay. Kathy probably says they shouldn't let me type in the public. So that's me actually. So yeah. So actually, I have female. I wanted to yeah, you see, you have female and male. The reason I wanted to see that it goes like one female, one male, but it didn't. When you do the set, it goes all the females first and then all the men. So it appended like that. So you see, it's stacked together, those 91 over the rest. So you have all the data together. Now, in this one, you can have HS master. In HS master, you can have t-test, right? So you can compare t-test. We will see that later, but let's do that for now. So product t-test, we run it, and it gives you like a t-test, and then all the for right. But we will get back to the right very soon, and we don't have much time, but yeah, that is very good. So merging data is another thing that is being done with SAS very easy. But the only thing that needs to be done when you want to merge two data, you need to sort the data by the variable that you want to merge data based on that variable. So usually there is one variable is the same in two data set, and you want to merge these two data based on that variable. And in here, that variable is ID. So there is a HS demo data set that you can see it here, that they have some observation, prog and female, and then there is HS test, which has ID and read and write. So this one has female and prog. This one has read and write, right? This one has 19 observation. This one has 18 observation. So if I want to merge these two, this ID need to be sorted first so they can merge them together. So sort the data based on the variable you define it here. So first you sort it, and then sort this one. Both of them need to be sorted so they can just compare each other. And then you can use data step and where to save. Again, it's very confusing, but where to save, which one to bring in to merge, right? By what you want to merge. And then if you run it, you merge these two data together. There is more on the merge. Merge is a lot. You have left merge, right merge. But now you see that in here, we have full merge. What I mean is, if that value, for example, this ID, you had values for female and prog, but you didn't have values for read and write. So that one is there. Also, this one that didn't have values in here, didn't exist in the first data set, but was exist in the second data set, that one is there. But left merge and right merge is keep one, merge the other one, that which is the right merge, and left merge is keep the second one and merge the left one to the existent one. So that one is left merge. So we really don't have time, and it's not covered in here, so I'm not going to talk about that. But in the resource here again, at the very end, you can see there is more on data manipulation and other resources that you can have here. And there is like more merging data using SQL, prog SQL, which is another procedure in the SAS. Okay. Now we go to analyze part. So analyze part means like we do like regression analysis, we do logistic regression, how we do. Okay, those analysis, maybe some of us doesn't have expertise in all of that, but at least it's good to have the memory of is there in the SAS, and those kind of type of analysis and statistical testing is in the SAS. I urge you, by the way, to go to our website, resources, and see what type of analysis in different software. If you want in the SAS, you can see that one. So analyze the data. T-test is the very beginning type of analysis. Oh, they start with the chi-square. Chi-square test, maybe for some is the first. For me, was T-test or Z-test. And for T-test, you can use prog T-test. Remember, we used another way too, right? But that one was univariate, right? If you want to test one sample test, but if you want to do two sample, then you need to do T-test. You can do one sample T-test or two sample T-test. So this is one sample. When you define your null hypothesis, so this is the testing, mean of the right is equal to 50 versus mean of the right is not equal to 50. So this is how you do that. If you want to know more about T-test, there is a page we have in the T-test in Stata. You can look at that. Actually, I'm going to show you right now. If you go Wish statistics, right? Or data analysis example. Some of them, like simple thing is better to go to Wish statistics test. And then you can see it here, like a one sample t-test, SAS, and then if you click on that, gives you the code, okay? So same thing here. And then you can use paired t-test, or you can use t-test using the class to do independent t-test. So the difference between these is for each participant, you have two scores. So these two scores are not independent. They both depend on these participants. So it's not really fair to treat these two sample as independent samples. So they are dependent. And so like couples or siblings are like that. So you use per t-test. If you want to, if you have two samples from two population, then you can do independent t-test, which you can use class and then variable. Okay, now ANOVA is one extended version of t-test. In ANOVA, you compare the mean, not between two groups, between three groups and more. So for ANOVA, in SAS, you use GLM, generalized linear model, but like in R, GLM is for all the generalized linear model, but here is for ANOVA. So the data is from here, right? We don't do data steps, so we don't have to be worried about. So this data equal. So when you do prog, you say data equal to this. Where in here? And then it reads it from here using class prog, and the model is right equal to prog, right? So it's like a regression when your the dependent variable is in left side, your independent variable in right side. And SS3 is a type of the test which is for balance samples. So is for unbalanced, sorry, for unbalanced design. So yeah, so this one does the job for you. Okay, after this kind of like prog, GLM, things like that, I see that there is a quit, right? That means stop it, like stop the job and run it and stop. I haven't seen, that's why I say like SAS is not consistent for all products. So some product have something that other product doesn't. So you have to be careful on that. So again, this one is ANCOVA. ANCOVA is like ANOVA. You're comparing three different mean, but you hold for other variable as covariate. So you compare the writing score for different level of program, given that the read score is constant. Okay, you fit, so you compare basically the mean of writing score for people who are program 1, 2, 3, like but only if those people have the same reading score. Does that make sense? And you assume that mean doesn't change with the reading score. So this is not a statistical class, so I'm not going to explain more than that, but yeah, so you can do it that and ANCOVA using. You can do regression using prog reg. There is other different way to do regression model, but prog reg is the simple OLS regression, and the data again. These progs, these analyses are very similar. So the data is here, And then you have your dependent variable equal to each of independent variable, and you just get it to run. And here we have different output, give the residual. So it created output data set in temporary, right? And then gives you like predicted value. So let's go and run this one. We will go on and run all of them. And this one saved some of outcome of the regression model more than it gives you predicted value, residual. So if that's how, if you want to save those variables or values. And then you can do logistic regression. Prog logistic does that. Ordinal logistic, also you can do prog logistic or multinomial logistic, but we don't go there. And there is a bunch of non-parametric that we already saw. You can use prog univariate. And there is another one is non-parametric one way, which is like a this is for two sample, and non-parametric one way you can use like for ANOVA kind of non-parametric ANOVA. There are more information here, but let's go and try to do some of those in SAS. So you can do frequency, but you see this is like a frequency table. The only thing is just we did here is slash chi-square, and then we ask for to show us the expected. So expected, and then, so before we had the only, so this is the chi-square value, but in here, we also added the expected value. So this is the expected. This is observed, this is expected. So observe, expected, and then calculate the chi-square. And then this is percentage, right? This is the percentage. So expected value, if they are independent, then what would be the expected value? And here it shows that chi-square shows there is no independence. That means for some academic level, more are in social economy 3 than the other academy or otherwise. So this is just a 2x2 independency test of chi-square. There are different like measurement for that chi-square. It's not only chi-square, like a Fisher, the Spearman chi-square. There are different likelihood ratio chi-square, which use likelihood ratio test. There is different type of chi-square that gives you the Kramer's V. I don't know what is that. I don't know those, but yeah, you can look at the annotated, probably that gives you, or you can search for. Okay, this is the t-test, one sample t-test. We run it. It gives us one sample with the normality test. So yeah, in t-test, we assume normality. But again, because the sample size is large, I don't even care about this normality, to be honest. So here, I do the per, and this is the per, which is the kind of like a one sample difference, and per profile gives you some other, and then look at the distribution of difference is very good. So, and then again, we can use the help to get those extra information. These two sample, now you see two sample, right? two different population, both are have normal. But it's not a test for normality. Normality is the assumption, is a really assumption for a small sample. You do the t-test this, and then you did the, yeah, two sample independent. We did that, right? I think we did that. Do it again. And then yeah. So again, I see the SAS is a little slower than some software in the very simple thing with the small data, right? Some other software are faster with the small, but they have trouble with the large data. So, you know, this is, so one way ANOVA, we did GLM. And this is I like this box plot because it shows you how different they are, even if they are not normal. So this is the median. And then you can do ANCOVA, not Mancova. Again, don't get confused. So this is kind of like a linear regression for different level of read, right? So that's why you get that, and gives you the analysis of variance results, sum of squares, mean squares, and F. There is REG, which is regression model that we. So this is kind of diagnostics, gives you the normality plot, things like that. So it looks good and those kind of things. Again, there is other workshops in the regression with SAS, things like that. Now, this one keeps that residual, not only plotted, but keeps that in a data file, right? So you can print and, or you can save it, but it gives you residual predicted value. If you want to plot it, then you can use this data to plot this data, okay? So that one thing, like SG and this is creating a new variable when writing a score is bigger than 60, because we want to run a logistic regression. So we have a 0, 1 variable. Now, if I do the print HSP2, okay, I don't print, I go to HSP2 and I show you from here. Right, I created a new variable, oops, this one, 0, 1. So this is my outcome. So in logistic regression, this is the outcome. So I can run the logistic regression. This is the outcome, and then predicted by female and read, right? So instead of just running a regression, I categorize with the logistic regression, and this gives you the result of logistic regression. And they're all non-parametric. You remember we did the univariate for mu, right? And then it gives us the non-parametric for free for one sample. So here, sign rank test, that was a free one sample against this means hypothesis for location, right? It's not a mean test, it's a location test for location, right? So if it's t-test, if it's t-test, then is the location is mean. But for this one is not. You can use the difference between this, like kind of pair, right? It's like a pair t-test, but in non-parametric format. You can calculate the difference and then do the non-parametric. No, we did that. The result is so okay. It's here. Yeah. So we did the difference again here. Right. Basic measure. New. Right. Yeah. For the difference between that two values in this data, right? I'm sorry. In this data. Read minus write. Oh, keep it in this. Okay. Okay. I'm sorry. What I'm thinking. So not univariate. I don't do the univariate. I just did create a data that create a difference in the read and write as a new variable. And then I did the difference. So difference, right? Okay. And then now, if you want to do two independent rank sum test or Wilcoxon rank sum test, you do that. Using, again, it's like a t-test when you have independent. And then you can do the extended version of rank sum when you have 3 group and more. Again, is non-parametric, one way, right? So it's like one way and a one. It calls course called Wallace test. So that's the Wallace test for different to these 3, and this is like empirical proportion, and there are lots of detail on that, but please over our seminar. So that's conclude our seminar.